Welcome back. Today we look at two examples from the topic of parallel lines. Let's look at the first example, which says find the equation of the line parallel to the line y is equal to 2x and passing through the midpoint of the points 1, 1 and 3, 1. Now let's understand the question properly. We have a line y is equal to 2x and we are asked to find the equation of another line which is parallel to this given line. And that parallel line passes to the midpoint of the given points 1, 1 and 3, 1. So let's see how we can go about finding the equation of the parallel line. Let's look at the solution. We are given the line y is equal to 2x and we are given the points 1, 1 and 3, 1. Now in linear equations in the form y is equal to mx plus c, the gradient of the line is the coefficient of x, and in this case the coefficient of x is 2, so this will be the gradient of the given line, and this also will be the gradient of the parallel lines because parallel lines have the same gradient. So we'll consider the gradient of the parallel line to be 2. The next thing we'll do is we'll try to find the midpoint of the given points 1, 1 and 3, 1. To find the x coordinate of the midpoint, we'll take the x coordinate of the given points, that is 1 from this point and 3 from this point, and we'll add them and divide by 2 to come in the middle, and that gives us a 2 as the x coordinate of the midpoint. Similarly, we'll find the y coordinate of the midpoint by taking the y coordinate from this point and y coordinate from this point and then adding them and dividing by 2, and we get a y coordinate of 1. So the midpoint that we get is 2, 1. Now that we have found the gradient and the midpoint, let's use the formula for finding the equation, which is y minus y1 is equal to m into x minus x1, where m is the gradient, which is 2 in our case. x1 is the x coordinate of the midpoint, which is 2, and y1 is the y coordinate of the midpoint, which is 1. Substituting these values and expanding this and distributing 2 inside to expand this bracket, we get 2x minus 4 on the right side. And this negative 1 on the left side will bring it to the right side, so we get the equation of the parallel line to be y is equal to 2x minus 3. Before we look at the next example, please remember to like, share and subscribe to this video. In example 2, we have find the equation of the line parallel to the line 3x plus y is equal to 6 and passing to the point negative 1, 9. Now in this example we are given only one point, negative 1, 9, and we are given the equation 3x plus y is equal to 6. So the first thing that will be doing is trying to find the gradient from this equation by first making y the subject of the formula. Our equation given is 3x plus y is equal to 6. So the first thing we'll do is make y the subject by moving this 3x term to the right side, and so we get negative 3x plus 6. So in this linear equation, we can see that negative 3, which is the coefficient of x, is the gradient. And as we learned from example 1, that parallel lines have the same gradient. So the gradient of our parallel line will also be negative 3. We have found the gradient to be negative 3 and the point given is negative 1, 9. So using the formula y minus y1 is equal to m into x minus x1 and substituting the value of m as negative 3, x1 is negative 1 is given in the question, and y1 is 9. And you can see here we have got two negative signs, so this will become positive. So when we expand this bracket by distributing negative 3 inside, we'll get negative 3x, and negative 3 multiplied with this positive 1 will give us negative 3. Shifting this negative 9 on the right side, we get the equation of the parallel line as y is equal to negative 3x plus 6. Thank you for learning. Please share your knowledge with others and support our effort.